Alright, YouTubers, we're going to continue with our lesson on solutions and stoichiometry. And now we're going to talk about what you need to do in order to dilute solutions from a more concentrated solution. In the lab, when we buy chemicals, right, especially chemicals that are in a liquid form or dissolved in water, these are known as, like for example, acids or alkalis. Okay, and the acids and alkalis that are in concentrated solution usually come in concentrated solutions, like 12 moles per cubic decimeters. All right, or molarity. Okay, and you are asked to maybe perhaps when you are helping out your teacher to make more solutions out of this stock solution that you have, this stock solution that you get from the lab room. Okay, so here is just a scenario that you may be asked to do. Your teacher asked you to make 20 cubic decimeters of 0.5 moles per cubic decimeter of hydrochloric acid from a stock solution of 12 moles per cubic decimeters. Now, I'll just like to highlight this, that this symbol here is called molarity. All right? Or if you use it in a conversational term, you will say molar. Okay? And molar is simply moles over volume. All right? Volume is a solution. In this case, water. So from a stock solution of 12 molars hydrochloric acid, calculate how much stock solution you need to add into the volumetric flask. Now, when you have a stock solution, let's say you have a bottle from the lab, right, a big bottle, you need to pour this into a measuring cylinder, okay? And the measuring cylinder, the contents in the measuring cylinder will be poured into a volumetric flask, okay? It will be poured into a volumetric flask. And the question is, how much of the stock solution you need to pour into the measuring cylinder before you pour it into the volumetric flask? So here are the steps. So you obtain the stock solution from the lab, and the stock solution is usually in a high concentration. In our case, it is 12 molars of HCl. And now you need to calculate the amount of stock solution needed to pour into the measuring cylinder. So you will use this formula. M1V1 equals M2V2. This formula is simply a ratio analysis between the concentration and volume of one substance and the concentration and volume of another substance. In this case, this here will make it the stock solution. And this here is what your teacher asked you to make. All right? So what we need to know now is to calculate the amount of volume needed. So we know the concentration, right? And we also know the concentration of the solution you want to make. And we also know the volume of solution that you want to make. And so I will rearrange this thing by moving the 12 molars from the left side of the equation to the right side. And I'll calculate this. So 10 divided by 12. And that gives me 0.83 cubic decimeters. So this is the amount of hydrochloric acid I need to put into the measuring cylinder. So I'll take the stock solution and I'll pour in 0.83 cubic decimeters of that stock solution. Pour it in, okay? And then I'll take my volumetric flask. From my volumetric flask, I'll pour in about halfway through here with good distilled water, all right? And then I'm going to pour in the contents of my 0.83 stock solution into the volumetric flask. And then I'm going to cap the volumetric flask. I'm going to swirl it so that everything mixes out nicely. And then I'll open up the lid, pour in the rest of the water until I reach to the indicative mark. All right? So if the mark on the volumetric flask is here, I will fill up the whole thing up to that point. And then I'll recap and swirl it another time. Usually I'll do it in this motion. Okay. So that is how you would take a solution of high concentration and dilute it down to make multiple solutions of smaller concentration. It is just like when you go to the grocery store and you buy a can of concentrated cream of Campbell soup. You would take that concentrated can of cream of mushroom soup. You would pour the contents into what do you call that? Into a container, and then you would fill the empty can of soup with water, and then you would pour it into the container, and you will stir it onto the contents in a heated stove, and you get nice soup. But if you wanted a more concentrated soup, you would add less water in it. If you wanted a more dilute soup, you add more water in it. It's just that simple, right? The concept of mixing the can of Campbell soup that you have with water is the same concept as this.